All right, here we go.
Good morning.
Morning.
Sorry, I have problems with my camera, so I'll have it off, but I'm here taking notes. Good morning, Miss Anderson, Mrs. Anderson.
Good morning.
Good morning, Irma.
Good morning.
Do you remember me? I'm Lisette. I took the class with you for MSIS in Brazil.
Okay. I don't have the pictures up. So what is your name?
Lisette Guerra.
Oh, okay. All right. Well, welcome.
Thank you. It was a couple of years ago. I'm here to refresh.
Okay.
Okay, so it is 8 o'clock. I am going to go ahead and get us started. Good morning. We are ready to get started. Well, welcome to the Tri-Association Annual Educators Virtual Conference 2021. We are excited to have Irma Anderson here to present her session using learning progressions to accelerate mathematics learning. I believe this one's specific to K-5. During this session, yes, I'm correct in that, Irma. Yes, I'm K-5. Oops, excuse me. During this session, we want to provide you some reminders. Please keep your microphone muted unless you're asked to unmute. Use the written chat feature to ask questions and have discussions with other attendees related to the topic. We remind you this session is being recorded, as well as Irma and I have made sure that the slides that she is using today are going to be available on the Tri-Conference portal. So they'll be available with the recording in approximately a week, we're told. But so, you know, that was something that was asked yesterday. Her slides will be available. So let's give Irma Anderson a warm welcome.
Okay. Thank you. And welcome to our session on follow-up to how do we develop a learning progression? What does it look like when I'm doing it? I was going to do breakout rooms but because of the number we had yesterday, I decided I would not attempt it because we only have 60 minutes and 60 minutes, by the time we get to our breakout rooms and get back, we've lost a lot of time. And always something happens, somebody gets lost, and then I feel badly that they can't be a part of the conversation. So there will be no breakout rooms. So please post your questions in the chat, and we will allot more time today to questions than we did yesterday. We ran out of time. So let's get started. I'll share my screen. And as we said, you will get the slides along with the recording. So what we're going to talk about today is how do we build a learning progression? Because a learning progression helps us to keep the focus on the learning target, to keep the learning moving forward. So as we think about this today and think about what we talked yesterday, just a brief reminder of what we said yesterday is that when we're doing these, we are following the backward design, because in the backward design, it says we're going to be teaching a unit. When we look at that unit, the first thing that we do is we identify the target or the goal. What's the big idea and the skills that I want my students to have at the end of this unit? And so that learning target is critical. The next thing that we do is we say, what's my evidence that the student have achieved its target? Again, I remind you that learning is a progression, And as a result of that progression, that learning, the evidence, the acceptable evidence will be a performance or a product. So what is that culminating task that we want our students to demonstrate evidence of the learning? Then that third stage in understanding by design is planning that learning journey. And that's where we focused yesterday. What does this journey look like for students? If learning is a progression, what does it look like when I'm developing my understanding of any particular concept in mathematics? So we gave you a template. And by the way, I like this when it comes out of Margaret Hess's work, because I'm a very visual learner, and being visual, I need to have a good picture of where I'm going and how I'm going to get there, and knowing if my students are going to have access to this learning. So this is the template that I like to use. So how do we build a progression? That's what we want to work on today, because remember, this is my assessment plan. This is also my instructional plan. And so I have a roadmap to get me and to help me to move students to that goal or that target that I have in mind. I always call this my GPS system. It is guiding me along the way. But I also remind you, something I said yesterday, that learning is not linear. It's really all over the place. However, what is a learning progression? It's a projected pathway. It is a pathway that we can be assured that many students, this is the road to success for them. But if I have this projected pathway, and then I have students who are off the path, off the grid, I bring them back by scaffolding, differentiating, and etc. So this is a projected path of how the learning takes place. So that's my formative assessment, moving the learning forward. And of course, my pre-assessment is what gives them access to this learning. So the process is you need to know the target of the unit that you're teaching. What is the big idea you're trying to develop? And units, our curriculum is always built around the big ideas of our discipline. We identify that learning target. Then we talk about the building blocks. What's the knowledge? What are the skills that students will need in order for them to achieve this target? So we identify those building blocks, and then we also identify what will it look like when children are successful for each of those blocks, for each of those chunks. What's the criteria for success? And then what would be a common assessment if there's more than one of us teaching the class, but what would be a good assessment that would ensure us that students have evidence to move forward with that learning? So we identify the criteria for assessment, and we identify a good formative assessment to keep the learning going. Then we identify that prior knowledge, because learning across our curriculum, across our standards in mathematics, are built on a progression. Each year in math is not something new. It is built on what we learned the previous year. But that's how learning occurs. All new learning is based upon prior knowledge. So needing to know that prior knowledge. So as we look at this, I'm going to take you into a scope and sequence. And this happens to be from grade 3. If any of you use New York Engage, Eureka Math, Match Fish Tank, the new Open Up resources, all of the new digital curriculum is very nicely done on a progression. So this comes from New York Engage, Eureka Math, Unbound Education, whatever you call it. Has several names, but it all is the same scope and sequence. So if I look at this, in grade 3, instructional time should focus on 4 critical areas: understanding multiplication and division and strategies for multiplication and division within 100, developing understanding of fraction, particularly unit fractions, developing understanding of a rectangular array and of area, and describing and analyzing 2-dimensional shapes. Those are the critical areas. So when you look at a scope and a sequence, you would expect to see those critical areas jump out at you when you look at what are the topics about. And in this one, as we could do with all the others, we will see that's critical area 1. That also is critical area 1. That also is critical area 1, because remember, multiplication and division is the big idea in grade 3. And then 2 fractions is there. Then we have 3, which is rectangular arrays. And then we have 4, which is geometry. Now, they have a module on displaying data. Some curricula will embed the data into geometry or into multiplication and division. So, but here again, these, I see the critical areas. So I know that I'm developing these 4 big ideas for grade 3. So let's take one of those and let's build a learning progression. How do I do that? I identify the target of the unit, identify the building blocks. I put them in a good sequence. And then I look for a criteria for success, assessment, and then identify the prior knowledge. So let's start. And we're going to go back to what we saw here, module 1. And I'm going to do properties of multiplication and division and solving problems, units 2, 5, and 10. Now, in some cases, some people like to put these together and do all of the units, but this particular curriculum does use 2, 5, and 10 first, because 5 and 10 are our friendly numbers, our basic numbers. And then we want to make sure that we have that before we go to other numbers. But if I look at that module 1, there it is. What is the target of that unit? So I always go in and I say to teachers, read the overview of what this unit is about. What is this module about? And so if I look at that module, notice what I found. What I found was, my computer gets to working, right? What did I find here? I can use the properties of multiplication and division to solve problems within units of 2, 5, and 10. Notice my target is about a performance, because that's what mathematics is about, which we talked about a lot yesterday. It's not about just learning skills. It's about performing. What do I want my students to be able to do? The idea behind mathematics is to solve problems. So I can use what I've learned about multiplication and division to solve problems with units of 2, 5, and 10. Now, if I did all of the units, I would say just to solve problems. But that's my goal. That's my target. That's where I want everybody to be. So the next thing that I do is, what are the building blocks? What are those building blocks? And so when I look at this, I go back into the module and I look at, and the nice thing about the new digital curriculum, it'll go topic A, B, C, D, E, F. They have written that as a progression. Now there's tons of lessons, as we're going to see, but they've written it as a progression. So when I look at that, I take a look at what is that about? Notice what I see here. Topic A is about multiplication and the meaning of the factors. So this is all about understanding that when you build an array, the dimensions of the array are called factors. Topic B is about, division is about finding an unknown factor. And we always teach multiplication and division together. We don't teach it separately, we teach it together. Topic C is about taking a look at arrays with units of 2 and 3. How do we multiply? Then topic D is about analyzing arrays to divide with units of 2 and 3. Topic E is about multiplication and division, seeing how they are inverse operations using units of 4. And then topic F is about distributive property and problem solving using units of 2, 5, and 10. So I have an idea of a progression here. So now I take a look, and here's where I said all these lessons come in. And in every curriculum, whether you're using a textbook or whether you're using any of the new digital curriculum, there are far more lessons than you have time to do. So we have to be very selective about what we're doing. So I take a look at this first topic A, and it says lesson 1's going to be about understanding equal groups. That actually is something I did back not with multiplication, but I've been doing groups. Sorry, I don't want to, I'll take my finger away from my computer. I've been doing groups since early elementary, primary school. We talked about groups. We didn't talk about multiplication, but in grade 2, we talked about when we have equal groups, how do we create an array? And now in grade 3, I'm going to say, when I build that array, that the size of the group or the number of groups is what a factor is. So that whole first section, topic A, lessons 1, 2, and 3 is about, I can use an array to interpret the meaning of factors, meaning the size of the group and the number of groups. So think about that. I have 6 objects and I went to put them into groups of 3. How many groups do I have? Or I have 6 objects and I went 3 in each group. How many groups can I make? That basically is what this is about. Can you use an array to interpret the meaning of a factor? When I look at the next one, I see it's about meaning of the unknown, the size of the groups. Now I'm doing division, understanding the meaning of unknown, interpret the unknown in division using the array model. So I can use an array to interpret the unknown. And that's what I did at first. If I have 8 objects and I went 4 in a group, how many groups will I have? So finding the unknown factor is division. Then we look at the next one. I can use an array to model the distributive property as a strategy to multiply. Okay, think about the array. If I have a 3 by 4 array, do you have a picture of that? A 3 by 4 array. I could have 3 groups of 1 and 3 groups of 3. I'm building that understanding of distributive property. Suppose I have 4 groups of 8. I can have 4 groups of 1 and 4 groups of 7. I can have 4 groups of 4, 4 groups of 4. I can have 4 groups of 5 and 4 groups of 3. But when I build those arrays and I can look at them as different groups, I'm building the understanding of distributive property. Then the next one is I can use arrays and number lines to interpret the quotient as the number of groups or the number of objects in each group, the 2 types of division. How many groups do you have? How many objects are in each group? And then we go to E, I can use number lines and arrays to model the relationship between multiplication and division. And finally, the last one, I can use the properties of multiplication and division to solve problems with units 2, 4, 5, and 10. So if you take a look at this, this is a progression of learning to develop an understanding of multiplication and division with units of 2, 5, and 10. First of all, what is a factor? Secondly, what is an unknown factor? The next one, what's the distributive property? The next one's about using both number lines and arrays to talk about the meaning of division. Number of groups, how many groups? Over here is about using number lines and array to show the relationship between multiplication and division. And then finally, we're reaching the goal of where we want to be. I can use the properties to solve problems with 2, 4, 5, and 10. So I want you to think about a unit you're currently working on. And I want you to just stop for a minute and reflect on how you approached that stage 3 of developing a progression for learning. What was the goal? What were the building blocks? Now, this brings us back to our standards, because the standards, the skills are not a checklist. The traditional way that we've taught mathematics is I teach you a skill, you practice a skill, and then we might do some word problems. If we look at all of the research coming out of NCTM and other groups, it says, let's turn math teaching upside down. Let's have a goal for the learning. And through good, rich problem solving, children will develop the skills. Now, you need to know what the skills are because you want to make sure that students have the skills. So if I put this into a progression, look at what I have. I have my journey. I can use an array. So when I look here, what is it that my students would need to know in order to be able to have evidence that they have this particular chunk? All right, think about that for a minute. I need to know what an array is. I should have learned that back in grade 2, because one of our standards in grade 2 is that I can identify a 5 by 5 array. I should be able to say that that would be 2 groups of 3, 3 groups of 4. And when I think about that array, I have rows and I have columns. So if I have 4, 4, 4, 4, I have 4 groups of 4. So that's basically what this first chunk is about, because this is going to give me access to everything else I'm going to do. So the second one, I can use an array to interpret the unknown in a division problem. I give you 20 blocks and I say to you, can you arrange these in 4 rows? How many would be in each one? 5. Suppose I want you to arrange them 10 in each row. How many groups would you have? That's basically what this is about. Notice we're constantly using manipulatives, using drawings, and we're also writing the number sentences. I can model the distributive properties. Well, let's say that I give you 12 blocks. How would you arrange this in 2 groups? It would be 6 and 6. But I could also say that it could be what? 2 and 4. It could be 2 groups of 2, 2 groups of 4, and so on and so forth. That's what that's about. I can use arrays and number lines. So now we build our array, we draw a number line, and we show the relationship between the number line and the arrays. That's what that one's about. And then I can model the relationship between multiplication and division. But doing this, I'm also doing some good problem solving with some good word problems along the way, because that's how they're going to learn the math. Then I can reach my goal. I have my summative assessment. However, what we said yesterday, if I take a look here, take a look at my standards, because this is a big part that I find that sometimes we misinterpret. Remember, our standards are domains, big ideas, clusters, standards. So this is a cluster. This is a cluster. It's a learning target. I can represent, what does it say? And solve problems involving multiplication and division. What are the skills that I need to do this? Well, if I think about the skills, these are my standards. I can interpret whole number quotients. I can use to solve word problems involving equal groups, arrays, and measurement quantities by using drawings and equations with a symbol for the unknown. And I can determine the unknown in a equation. What I want you to see is domain, big idea here is multiplication and division. A cluster, I can represent and solve problems involving multiplication and division. And then look at our standards. They are skills. They're not a checklist, but you have to keep in mind, what is this all about? They have to be able to talk about groups. They have to be able to build an array. They have to be able to write an equation. They have to be able to use drawings as well in order to solve problems involving multiplication and division. Now, look at the next cluster. I understand the properties of and relationship between multiplication and division. Can I apply the properties of operations? Doesn't need to know the formal terms, but can I see what a commutative property is? That 2 groups of 3 is the same as 3 groups of 2. Do I see the relationship with the associative property? That 3 groups of 8 are 3 groups of 3 and 3 groups of 5. That's a distributive property. If I'm given the number of objects I have, and I know I want the size of the group, can I find the other factor? And then the third cluster is I can multiply and divide within 100 using all those things that I've learned previously. And then, of course, our ultimate goal is, because they've done addition and subtraction in grade 2, we want to make sure that they can add, subtract, multiply, and divide using all these orders of operations. So the big idea here is we have domain, big idea, we have clusters, which are learning targets, and then we have the skills, which are the standards. Now, standards are skills. When you have skills, you can either use that skill or you're approaching that skill. In other words, interpret the products of whole numbers. You either got it or you're approaching it. You can't exceed that. I can exceed at problem solving, and I can exceed at constructing an argument of why my solution is correct. So we have to keep that in mind. This is why our skills are not a checklist. Been there, done that, and move on. It is, what is the purpose of these skills? What am I trying to do with these skills? I want to be able to represent and solve problems involving multiplication and division. So when we're finished with that, the question we have to ask ourselves is, do my students have access? And that access comes from the foundational standards, which, if you look at, and I'll show you here in a bit with the, I can't think of what I was saying, the live binders. In a bit, I'll show you that those foundational standards are found in that coherence map. So what did they do in grade 2? They determined whether a group of objects up to 20 has an odd or even number of members. Remember, that was if I gave you 12 blocks, could you put them into an array? I could put a 1 by 12, I could put a 2 by 6, I could put a 3 by 4 or 4 by 3 or a 6 by 2. Even though we didn't talk about the factors, that's what we were doing when we had those manipulatives. Suppose I gave you 13 blocks. Can you arrange them into equal groups? And of course, the answer was no. So we had the definition of odd or even. And that was grade 2. Then we used addition to find the total number of objects in a rectangular with up to 5 by 5. And we've learned to skip count. So think of, those are the foundational standards that will give me access to what I'm going to be doing in grade 3. So we need a pre-assessment, because my pre-assessment should be on what it is that my students will need to gain access to this new learning. So in that backward design, I've identified my learning target, the goal of the unit. I've identified my performance or product that I want, or I have identified the journey. So let's take a look here. This comes from one of our schools. I can use the properties of multiplication and division to solve problems with units of 2, 5, and 10. And I just shared a couple of their problems that was their summative. Mr. Dent needs 86 markers for his 3rd grade classroom. He has 32 markers in his desk. He wants to buy more markers and finds that the new boxes have 9 markers in each box. Explain to Mr. Dent how many boxes of markers he should buy. What I want you to notice is a good summative assessment is about problem solving. It's about constructing a viable argument or critiquing what someone else has done. All of that is here. It is not a word problem. It's a good problem solving situation. Because remember, that's what problem solving is. Problem solving is defined as knowing what to do when you don't know what to do. So he needs 86, he has 32. I need to know how many more does he need. So he finds out that he needs 54. However, they come in boxes of 9 each. How many boxes should he buy? And then explain to Mr. Kent why he should buy a certain amount. Another one that comes out of one of our schools, Sheldon is helping his mom bake cookies. He has 3 trays that are the same size. On one tray, he makes 5 rows, 4 cookies. He cannot fit any more cookies on the tray. He fills a second tray and only part of the third tray. How many cookies should Sheldon have made? Now, I know the pushback we get, and people will say, my kids can't read word problems. Well, our children need to read word problems. And remember, one of the strategies beginning back in kindergarten is what we call the 3 reads or using numberless problems. Think about it this way. We build this perseverance for solving word problems because that's what mathematics is about. It's about problem solving. So in the 3 reads, or let's do the numberless problem first. I like to put them together, to be honest with you. Mr. Dent needs markers for his 3rd grade classroom. He has some markers on his desk. He wants to buy more markers and finds that the boxes come in a certain amount in each box, period. Let's talk about that story. What is the story about? Because that's what math is. It's about a story. He needs some markers, but he already has some markers. But the markers come in boxes. This is how we develop that language for mathematics, and that's stamina for solving problems. So that's my first read. My second read is I'm going to put in he needs 86, he has 32, they come in 9 markers. And I'm going to talk with students about what does that 86 mean? What is that 86 about? What does it stand for? It stands for the number of markers he needs. What's the 32 about? It's about how many he has in his desk. What's the 9 about? The 9 is about they come in packets of 9. Draw me a picture of what that would look like. Things like that to build that idea of how we do a math problem. Then the third read is what might be the question? Here now, then we insert the question, but keep the question out until the third read. How many boxes should he buy? Now, this comes out of all of our literature on how do we build stamina. It begins back in kindergarten. 3 children were on the playground. 4 more children came to play. How many children on the playground? Some children are playing on the playground. Now some more children come to play. And then talk about what's the picture? Do you have a picture of that? Draw me a picture of what it is. Some children are here, then here comes some more children. Now let's put in the numbers. 3 children are playing. What does this 3 stand for? It stands for how many children are playing. 4 more came. What does that look like? 4 more came. Draw me a picture, and so on. So you can build that stamina and help kids, because I cannot separate the literacy from the mathematics. I cannot separate the social and emotional goals, because if I don't feel good about a problem, I don't feel good about mathematics, because this is where a lot of the students, the breakdown begins is I can't do math because I can't do word problems. But that's what mathematics is all about. So this is my summative assessment. I went off on a tangent there, but that's okay. It's about helping our students to develop this perseverance for what mathematics is all about. So then the learning journey, we have it planned, we have a progression, but the question I have to ask is, do they have access? And so let's look at those foundational standards. Now, if you look at this, and sometimes we read the problem together when we're doing a good pre-assessment to make sure that children have access, because we don't want the vocabulary to be a problem. We want the math to be the challenge. So Lynn wants to put some red and blue tiles on a wall for decoration. She's thinking of different patterns. She wants to choose a pattern that would let her use exactly as many red tiles as blue tiles. And then, is it possible to create this pattern using the same red as blue? Is it possible to create this one? Can you figure out how many tiles are in the pattern without counting them? So it's leading to that idea of what do they know about arranging, about looking at patterns, about odd and even, which you notice are the foundational standards. And can I build that array? Can you tell me the number in this picture without counting? Is it possible that this kid had the same number of red as blue? So these are the kind of pre-assessments we want to give, not just a laundry list of naked numbers. It doesn't tell us about their thinking. And we want to know about what they're thinking. So pre-assessment. Now we come back to where we're at. We know whether our students have access by our pre-assessment that we give. And then we begin this journey. And as we begin this journey, keeping in mind, this is about identifying factors. This is about identifying an unknown factor. This is about using array. This is about now using arrays and number lines to interpret division. And then this is about looking at multiplication and so on to get to where we're going to be. So we build a common assessment. If there's more than one teacher in the grade level, we need a common assessment. If I'm the only teacher, I need to have, what does success look like? What does success look like when I have achieved that goal? What is it like? So what is my assessment to see if I can move the learning forward? Remember, these are my formative assessments. And what is formative assessment? It's about, well, let me give you the definition. It's a planned process that allows me to analyze the learning and make decisions about instruction and learning for each child. It's a planned process to move the learning forward. It's about achieving the goal. How do we move this learning forward? So I have to be able to do this, to do this. So let's go back. This is an example of a common formative assessment. Oh, sorry. Good grief. Common formative assessment. I'm getting there. So packs of juice boxes are shown below. How many equal packs are there? How many juice boxes? What is the total? Write me an arrangement of juice boxes, because that's what it's about. Can you talk about the factors? What is the factor? Build me an array. What's the size of the group? The size of the group is 3. How many groups are there? There are 5. And those are the kind of things that we want to relate to say, oh, they get it. Now we're able to move on. But if they're not able to move on, remember, we scaffold the learning, because now we're going to be still doing arrays. I can build in some of what might be a gap with certain students as I'm doing this. So let's take a look here. I'm going to go back to the New York Engage, Eureka Math, and I'll show you here in a bit. It does not make a difference. It's all really very similar. Then we take a look. I'm going to look at Module 1. Sums and differences to 10. Look at the topics. Embedded numbers and decompositions, counting on, word problems, strategies for counting on, commutative property and the meaning of equal, development of addition fluency, subtraction word problems, decomposition, and development. That is a progression for developing my understanding of sums and differences to 10. Because back in kindergarten, here's what they did. They could count forward instead of having to begin at 1. They understood that the last number said tells the number of objects counted. That's my conservation of numbers. The number of objects is the same regarded of how they count them. This is a critical part of our mathematics, because remember, allows me to have that flexibility with numbers. For example, if I'm adding 28 and 82, I can rearrange those numbers into 20 and 80 and 8 and 2, and I've not changed the value. So conservation of numbers is a critical thing that we learn in kindergarten. Understand that movement about 1 more refers to a quantity that is 1 larger, which takes me back. Notice mathematics is not about numbers. Mathematics is about quantity, that one-to-one correspondence that we learn. And one of the biggest gaps that kids have, even in middle school, is not understanding that a numeral represents a quantity. 3 represents 3 birds, 3 flowers, 3 children, 3 whatever. It represents a quantity. So when children see and understand one-to-one correspondence, it all begins to make sense. I share with you this. I was in, and if you heard this story before, it's okay, but it's stuck with me for the last couple of years. I was in a first grade class in one of our schools. And when I walked in, the teacher had written on the board, 3 + 4 = 7. And the warm up for the children was to write the story. Tell me this, what's the story here? All 18 students in that classroom wrote a story about 3 + 4 = 7. 3 birds were on the wire, 4 more birds came, and now there are 7 birds. And it was very simple things like that, but they all had a story. Same day in a middle school classroom in the same school, I sat down beside a young man and the teacher gave them 10 equations to solve. The first one said 2x + 3 = 13. He sat there and he tapped his pen. And finally I leaned over and I said, "What are you trying to do?" And he said, "Find x." And I said to him, "What is the story? What does this equation represent? What's the story?" And he looked at me and he said, "Miss, this is algebra." He had no clue that 2x + 3 = 13, that if I would have taken that back to that first grade classroom and I would have put box + 3 = 13, I would have bet every one of those students could have written me a story because they understood one-to-one correspondence. He had no clue that 2x represented a quantity, 3 represented a quantity, 13 represented a quantity. He had no idea that that was the meaning of it. So going back, this is what kindergarten is all about, and we have fluency within 5. Now, go back, this is basically my kindergarten math curriculum about rote counting, about rational counting, about cardinality, knowing the last number set is how many objects there are, conservation, knowing I can rearrange, irrelevance, it doesn't matter whether I count left to right, top, down or back, it doesn't matter the order in which I count, I still get the same thing. Subitizing, which leads to arrays, being able to look at things as a group instead of counting each one individually. Put out 6 marbles. How do students count them? Most students in KM1 have difficulty because they can only subitize small numbers. Think of yourself. My phone number is subitized. It is 3 digits, and 4 digits. My social security number in the US is subitized because as an adult, I can only group 4 to 6 objects. Movement is magnitude. That's that one more till we get to place value. And remember, place value in kindergarten is about counting on. You have 10 objects, 1 more makes 11. We use the 10 frame. So let's take a look here. And if I take a look at these lessons, I notice what I said originally. This is all about problem solving. This is how we learn to add and subtract. Put together, add 2 with result unknown, put together, add 2, change unknown, put together, add 2 with result unknown. And I could go on and on and on. My early grades, kindergarten, 1st and 2nd grade, fluency is acquired through good, rich problem solving. And remember, it goes on, remember, all the math story problem types were given to us in our standards. These are the types of problems that students must be able to solve by the time they leave 2nd grade. Now, kindergarten only works with result unknown and change unknown, and result unknown and change unknown. That's all these are the 4 they work with. However, grades 1 and 2 work with all of these. So that's why you see these in our standards. So I develop these lessons, but I use a lot of good word problems. So that has to be in my targets that I write. What are the models I use? The part whole and number bonds and the number line are the models that we see in the standards. So keeping that in mind as we work here. Now let's go back and let's think about what we have just done. This happens to come from one of our schools, the progression for, I think this is second grade, I think, or no, it's first grade. I don't remember. I think it's first grade. I can apply the identity property as a strategy and subtract. I can add within 12, fluency from within 10, using doubles, near doubles, 10 frames. I can use the concept of 0, less than, 1 less than, and use addition facts. I can add and subtract within 20. Notice how we're just building up with the numbers. I can use the associative and commutative properties as strategies to solve word problems. Remember, commutative and associative, commutative property for addition and subtraction, and the associative property for addition and subtraction. And I can use my understanding to solve word problems. So as we look at this from our standards, this is how one school developed their progression. Then what all this is about is we have to fill the gaps by scaffolding the learning. Language we mentioned yesterday. Notice concrete representation before we get to the abstract. Specific guidelines for helping children to carry on these conversations of what we expect. Lots of good small group work, partner work, sentence starters, graphic organizers, and above all, the teacher modeling what they expect from the student. Now, I'm going to take you here, and then I'm going to take questions. projectarrow.org. And you may have found it. So if you go there with me, did everybody get that? And I'm going to get down here to guidance for 21-22. And if I look here under this tab, I will get, can you still see my screen? I better ask that. Thumbs up. Katie, can you still see my screen? Good. Okay. If you take a look here, under here, critical areas, these are the critical areas. Every grade level, every course, kindergarten through high school has critical areas. These are the K-8. Now, if I click on this, it makes it larger so that I can see it. But it describes what are those critical areas of each of the grade levels, K-8. So we're interested in K-5. So we can find our critical areas there. Then, if you want to know how some people looked at progressions, if I go here, assessment critical areas framework, and let's go to grade 2 since we haven't been there. These are the critical areas of grade 2. All right. There are 3 critical areas. And we talked about this yesterday: priority, supporting, and additional. So there are 3 critical areas, and these are clusters. These are targets, which also help me to write my learning progressions. I can use place value to add and subtract. I can represent and solve problems. I can add and subtract, and I can work with equal groups. However, if I want to look then at, let's look at the first one, and what a lot of schools did was to just build the progression for the critical area. So this is that progression of how can I read, write, and compare 3-digit numbers using a variety of representations, which is a critical area. First of all, can I write the numerals and number names? Can I count? Can I skip count? Can I bundle tens to make 100? Can I use models to show 3-digit numbers? Can I read and write those numbers? Can I compare 2-digit on the meanings using the symbols? And can I add and subtract tens, hundreds, 2-digit numbers? Now, let me just say something about this. I put up what they did, But one of the things I advise them on is if I'm going to share this, I want to make sure that I have problem solving in here because it's critical. So I can read, write, and compare 3-digit numbers using a variety of representations and use that understanding to solve problems. It's that simple. I have a hand up. What was the question? Go ahead.
Good morning, everyone. I am Jessie and I teach 3rd grade. And my question is, Irma, that what about right now that there are some kids that are like carrying on some gaps from, in my case, from 2nd grade? Should I add in the critical standards some of the main or critical things that they should know, but they don't? Because I was also thinking that I was checking the critical standards for 3rd grade and it doesn't include addition and subtraction of 3 digits with regrouping. So I was, in my case, I'm thinking that that's one of the main or critical points.
Okay, well, think about this. By the time I leave 2nd grade, I'm to have fluency with addition and subtraction within 20 and to solve word problems within 100, right? Now, if you think about, because addition and subtraction leads to multiplication and division. So what it would say, and what we would advise you to do is, I begin that unit with multiplication and division, which is about repeated addition and subtraction, is it not?
Yes.
Right? So I'm going to build in some activities with adding some 2 and 3 digit numbers into that as we build it forward. So that's what it means to accelerate the learning, because it is a progression. And I move from addition and subtraction. So I have children who come to me who are still not really good at adding and subtracting, or don't have that proficiency that we desire. So I'm going to build in activities because we're going to be adding and subtracting all the time. And you will build it. Because remember, a lot of times it has to do with age too. So this is why it says do not remediate. Don't go back and repeat to 2nd grade, because if you continue to do these rich exercises, it might click with some of the students. You might have to do some intervention, but it should not be many students.
Yeah, thank you, Miss.
Okay, I had another hand up. Who was it? Any other questions? No one. Well, let me ask you this. How comfortable would you feel of taking your material now and to write a progression?
Maybe we can try in teams.
All right. Who's willing to share a unit you're doing?
I can share if you want.
Okay. And what are you doing right now?
Right now we are starting, yesterday my kids did the relation between division and multiplication, early division, and like 5 families is
All
what
right.
they.
And Jessica, you don't mind if I question you, because I want everybody else to listen? This is not about anything you're doing wrong or anything, but I'm just going to ask you a question because I want people to think about this, okay? So will you play along with me?
Yes, I play, don't worry.
Okay, Jessica, so I'm going to say, Jessica, what's the big idea that you want kids to know after this unit is over? What is the big idea you're trying to get at?
Well, I want them just to get the early basic knowledge or what division is. So starting with, we started first with some word problems, easy word problems, like the teacher had 15 scissors and she needs to place them in 5 tables. How many scissors on each table? Sorry, how many kids or how many groups, whatever. And starting from there, from dividing with 2 word problems, then we jump in with the relation so they can start just, I don't know.
That's okay. All right, no, I mean, this is what
We
I really,
follow the everyday math program.
okay, all right. And I'll be very careful. I won't say any words, but I want you to think about it, because does it get to the big idea? Does it address a critical area? Because, and this is no reflection on you, but what I'm hearing is, which is a real issue, is that whenever we just teach a topic and a topic, kids never can put it together. So actually, what you really should be trying to do is, what we really should be trying to do is, what is the big idea here? And the big idea is that first critical area, multiplication and division. So let's think about what you said. The problem you asked is, I've done some things with multiplication. Absolutely, I'm going to draw arrays. I'm going to draw pictures. I might even start with giving them some manipulatives, some counters, and I might go back and start my unit by saying, okay, I'm going to give you 20 counters. Can you group those for me? How many different ways can you group them? Oh, I can group them. One group of 10 or two groups, da, da, da. And I would have one group of 10, I'm trying to think what I said, two groups of 10 from 20, two groups of 10, four groups of five groups of 4. So we would talk about all these different ways. And then we would say, can you arrange them into equal groups? Okay, I have a row of 10, a row of 10. I have a row of 5, 5, 5. And then I say, how can I count those? Because that gets back to really reinforcing subitizing. So you'd say 5, 10, 15, 20. That's that skip counting that comes in. Then when I'm done with that, we would talk about, oh, these are the dimensions of this figure, right? The array. How many groups do you have? And those are my rows. I have 4 groups. How many are in each group? There are 5. So now I have built what is an array, called an array. I call it an array. I get the one side tells me how many groups, the other side tells me how many are in each group. Those are called factors. So we want to build that idea of factors in multiplication. Now we're going to move to division. Oh, if I give you 20 counters and I want you to put them into 4 groups, how many would be in each group? We call that division, because the definition of division is finding the unknown factor. Now, let's go back and think about that. And I want everybody to think about this in terms of, let's say I want to divide 80 by 4. What does that really mean? It means I have 80 objects and I want 4 groups. How many should be in each group? And I'm not going to do long division. We don't use long division.
Irma, I'm sorry to interrupt you. I just want to give you your 5-minute warning and let you know there are a few comments and questions in the chat that I am happy to share with you, but just wanted to give you your 5-minute warning.
I will, but Jessica, that's what I want you to think about. What is the big idea? And then see, look at the progression that teachers have done, and that will help you. Even if you all just focused on those 4 or 5 critical areas and then used your resource, it makes such a difference. Go ahead, Katie. Jessica, if you want to talk sometime, just send me an email.
Thank you, Miss.
So there were a few questions, Irma, about this idea of what it means to not remediate. If you could elaborate on that, that seems to be a question that several people have.
I didn't understand the question.
So a few people said, I'd like to better understand what you mean when you say to not remediate. And they're asking some questions about how do we teach the skills that they've missed. So if you could elaborate on that.
The glossary for educational reform and the research says remediation. Here's how they define remediation. That, you see all of a sudden there's a gap. And what you do is you go back and you teach that 2nd grade unit all over again. That's called remediation. That's remediation. Now, intervention is different. I'm using the definition. So how do we help students who have gaps? That's where our pre-assessments come in. That's where our formative assessment, that common formative assessment comes in, or formative assessment in general, because I see where there are gaps. So it might be with 1 or 2 students. Then I'm going to make sure that I work with them individually. But if I have a larger group, then I'm going to scaffold into the next lesson that I have some of the things that are missing. That's what it means by acceleration. So the term remediation is going back and teaching a whole 2nd grade unit again in 3rd or 4th grade. How do you fill gaps? Because these are progressions. And the kids come with some knowledge. What are those gaps where we need to fill? That's the difference. I hope I answered that. But there's a difference between remediation and intervention. And that's what I was referring to. Other questions in the chat?
That seemed to be the main question, but there might be others or that, they might have follow-up from that.
Anyone else? I do want to encourage you to think about those progression because it has made a world of difference. I have a number of people last year in using the remediation saw what a change, what a difference it made. Knowing that big goal, knowing what those pieces are, those chunks are. And then how do we get there? On the live binder here, one of the things, if you want to see, I have, if you've never looked at, and I'm not promoting the digital curriculum, but even if you took a look at the digital curriculum that's online, Open Up Resources, Match Fish Tank, Eureka Math, New York Engage, Unbound Education, all their units look the same. They're just some difference in the sequence, but they look the same. But the nice thing is, if you look down through their topics, they are in a progression. So no matter what you're using, you can still refer to those progressions.
Okay, so it is 9 o'clock, Irma, and I've been instructed to really hold tight to that time because I guess the keynote begins at 9:05. So I know you mentioned your email address last session. It's globalmathteacher@gmail.com, correct?
Right. And
I'm going to
please
put it in the
email
chat.
me. And thank you, Katie, for facilitating, and thank all of you for attending. And any questions, don't hesitate to email me. I'll gladly answer your emails.
All right, everyone. Hope you have a wonderful day. Thank you for attending.
Thank you.
Thank you very much.
The email is global math teacher, right? Global
Yes.
math teacher @
Gmail.
Gmail. Thank you.